Hi, welcome to Cal. Welcome to the EECS Major Information Session. I'm Jeff Bokor, Chair of the EECS Department. That's Electrical Engineering and Computer Science to you folks. I'm also the Chair of the EE Division. The department does have two divisions, Electrical Engineering and Computer Science. I'm the Chair of the EE Division, and I'll be giving you this introduction to the EECS major today. Well, first off, congratulations to those of you in the audience who are admitted. This talk is mainly intended for new first year and junior transfer admits, but of course, everyone else is welcome to listen in and to go to hear about our program. Maybe you're considering applying in a future year. We're glad to have you, and we hope you'll find this to be an interesting introduction to the department. So first of all, let me start with kind of an overview of the whole department. And I want to start off by introducing these two outstanding women to you. These are our leaders at the college level. On the left is Professor Sujay King Liu, who is also a member of the department and is the dean of the College of Engineering, which means that she's a leader for the whole college, which includes other majors like mechanical engineering and civil and environmental engineering and etc. We have a new unit that the EECS department is also part of, called the Division of Computing, Data Science, and Society. A new unit really that's been formed to promote the new field of data science, including an undergraduate major in data science, some of you may be aware of. The leader of that unit is Jennifer Shays, who is recently joined UC Berkeley and is also a member of the EECS department as a faculty. Now, we have a mission statement for the department. The three fundamentals of our mission are to create knowledge. And for us, that means both fundamentals, the basic science that underlies electrical engineering and computer science, and of course, the development of the technologies that today are so important to society that we are contributing to. We also have a very strong element of interdisciplinary collaboration in the department. So first of all, we are a joint department of both electrical engineering and computer science, and there's very strong interaction, really a seamless interface between those. The electrical engineering to create the hardware and the computer science to create the computing on that hardware that underpins all the information technology that we know and love. Our second mission is to educate future leaders, and that's you folks. We aim to create leaders, to help develop leaders, that is to say, in all three of all of these pursuits: academia, government, industry, and entrepreneurial. That means new companies, new industries. And last but by no means least, we have a very strong culture and commitment in this department and really throughout the Berkeley campus to be in service to society. And that's at all levels, the local, national, international level. And everything we do is deeply rooted in an awareness of our responsibilities to society and to conduct our research and our teaching with the highest ethical standards. Now, Berkeley is one of the top programs in the country, and here are just some recognition of that. Our undergraduate programs are rated in electrical and communications engineering. We're right up there in the top 3 with MIT us in Stanford in computer engineering, Carnegie Mellon, MIT, and Berkeley. Overall, in terms of best colleges of engineering, we also within that same sort of top 3. Our graduate programs are also extremely highly ranked on the essentially the EE side, electronics, communications engineering. In 2020, we were ranked as in a 3-way tie with MIT and Stanford. Same thing in computer science in the most recent ranking. Carnegie Mellon, MIT, Stanford, and Berkeley all tied in that particular evaluation. Now, let me tell you a little bit about our department today. We have about 110 regular faculty members in the department, as well as 30 very active emeriti, that means retired faculty, as well as other kinds of titles like professor in residence and adjunct professors. These are people who are part of the department, but may also have some connections in other places as well, other parts of the campus or maybe in industry, etc. We have 710 graduate students this year, and that breaks down as 550 in our PhD program and 160 in our master's programs. We have 2 major master's programs. One is called Master of Engineering, and we also have a program for our own undergraduates to stay on for a 5th year. We call it the 5th year master's degree program. It's a Master of Science program. Now, here's the number you're probably most interested in. We have almost 3,500 undergraduate majors in our department. And that includes both the EECS major and the computer science major. I'll tell you a little bit more about that coming up. So about half in the letters and science computer science program. And, you know, the other half in the College of Engineering. It's a Bachelor of Science program in EECS. And I'll have more to say about these two paths into our major, letters in science for a BS and College of Engineering, letters in science for a Bachelor of Arts degree. And the College of Engineering, those of you who applied to the EECS department in the College of Engineering would be going into a BS program, Bachelor of Science program. Now, the department is large, as I just tried to illustrate, with 110 faculty, lots of grad students, and a huge number of undergrads. So we don't fit into one building. We are mostly housed in 6 buildings, although we have some spaces in other places as well. Up in the upper right-hand corner here, Corey Hall is kind of the home base for the electrical engineering division of the department. And down here on the lower right, Soda Hall, across the street from Corey Hall, is the home base of our computer science division. But we have faculty spread out in all of these other buildings. Sutarjadai Hall, which is right next to Corey Hall. Jacobs Hall, which is right behind Soda Hall. Berkeley Way West is down and closer to downtown Berkeley, is the home of our Berkeley AI Research Center. And over here, the Calvin Lab is the home for a Center for Theoretical Computer Science called the Simons Institute. Now, we're very proud of the fact that this is a unified, integrated electrical engineering and computer science department. And we span the whole range of the discipline from at the kind of, we like to think of it as a stack. And down at the bottom of the stack is the fundamental technologies, materials, and physics that underlies electronics. And so you see over here on the left-hand side, energy, physical electronics. That means, you know, transistors and LEDs and lasers and things like that. nano electromechanical systems, integrated circuits. And as we move into the interface, where we merge from electrical engineering into computer science, you see a lot of different aspects: computer architecture, imaging, networking, cyber physical systems, which basically means robots and Internet of Things and so on, control and robotics. And then as we move into the upper side of the stack, the upper end of the stack, in computer science, graphics, programming systems, databases, scientific computing, artificial intelligence. And really, these are seamless. All of the stuff that runs on the right-hand side here, all the software systems are running on hardware systems that are being developed. And these days, you can't really separate these things. As the technology is becoming more mature and more sophisticated, systems are really being designed with the ultimate software applications in mind, but and with the hardware being optimized more and more to run particular types of computing systems. Most notably, we're seeing more and more specialized hardware, for example, for artificial intelligence. Now, I already mentioned once we have two bachelor's programs. You may be admitted to one or the other. The first one, the one that I'm mainly talking about in this talk, is our Bachelor of Science degree in Electrical Engineering and Computer Science, which has its home in the College of Engineering. This has a little bit greater emphasis on physics and math, but as you'll see, it spans the entire range of the department that I just showed in the previous slide. Where I say greater emphasis on physics and math is because it's a Bachelor of Science degree, you would have a few more requirements on the basic science side in this program. Whereas the Bachelor of Arts program is particularly emphasizes computer science. Its home is in the College of Letters and Science. So students apply to the College of Letters and Science have the option to take this computer science degree. And it has somewhat of a greater emphasis on humanities and social sciences, since its home is in the College of Letters and Science. However, these differences that I point to, science versus humanities and social science, have to do with the requirements outside of the major. The way that these two majors are structured is that the coursework that you take in electrical engineering computer science is actually, the requirements are essentially the same in the two different degrees. And I'll show you some more about that in the next couple of slides. So all of our students in either of those two majors are required to take courses, what we call the lower division. That's the fundamentals, the junior and senior level, the freshman and sophomore classes. There are 6 of those. I'll tell you the names in the next slide. CS 61 A, B, and C, CS 70, and then hardware-oriented classes, ECS 16A and B. So our lower division courses cover the whole spectrum from hardware up to programming systems, computer architecture, computer science theory, etc. And so everyone in the major, whether you come through the Bachelor of Science program in the College of Engineering or the Bachelor of Arts program in the College of Letters and Science, all students have to take these 6 required courses that give you a fundamental introduction across the entire field of electrical engineering and computer science. Now, in the upper division, once you've taken these 6 required courses, you have a huge amount of freedom to choose your junior and senior level courses from all these different sub-disciplines within electrical engineering and computer science. And over here on the right-hand side, we have more of the hardware side of things: power systems, physical electronics, transistors, and integrated circuits and lasers and LEDs, through control systems, robotics, computer signal processing, up through computer architecture, communications, systems, computer security, and now we get over here into the more of the CS-centric courses, databases, graphics, artificial intelligence, and so on. And in the upper division, you have essentially, you have a requirement to take about 5 of these courses, 20 units, but you have complete freedom to, almost complete freedom to choose from all of these different disciplines. You could focus all of your upper division courses over here towards the right-hand side on the hardware side of things, or you could focus all of your upper division classes over here on the left-hand side in the more in the computer science area, or you can mix and match and you know, experiment and try out and see what things interest you. And a lot of our students, you know, pick a selection of courses from across the spectrum. Today in industry, I can tell you that many of the companies that recruit our students really appreciate having the opportunity to bring in people that have a good solid foundation in both the hardware and the software side, because more and more, as I say, information technology, information processing systems are being very intimately, the design is intimately involved in both the optimizing the hardware and the software. So you have to know a little bit about the whole system in order to be the most effective in today's advanced technology development. Now, on top of these courses, which are the requirements within our major, these are all EECS classes or CS classes or EE classes. In addition to that, you have additional requirements that give you breadth, science and math, ethics, and various electives. And these, the requirements within the major are the same for the EECS College of Engineering students or the CS Letters and Sciences students. So here's a little bit more about our lower division courses. These are the 6 that I mentioned. So we have a 2-course sequence, EECS 16A and B, Designing Information Devices and Systems. And this is really on the EE side. You learn about hardware, you learn about also what we call systems, thinking about signal processing and control systems and the like. Then we have 2 very much sort of on the hardcore programming computer science classes, 61A, Structure and Interpretation of Computer Programs. It's not just a pure programming class, but really teaches you kind of the underpinnings of, you know, how computer software is really structured. And, you know, you learn not just how to program in one particular programming language, but really how programming is thought of at the higher level. 61B is a course in data structures, which is very, very much fundamental in all software today, various ways of representing data and processing it. Now, 61C is a course that really bridges the hardware and software side. It's called Machine Structures. It's really how computers are built at an architectural level, how data is processed in a computer, how the computer executes the software, and how to optimize it to get the highest efficiency and then make our computers run as fast as possible. That's a course which really bridges between electrical engineering and computer science. And then last, CS 70, which is really kind of a math and theory course on discrete mathematics and probability, which is also fundamental and necessary for people on both sides, the EE and the CS side. Okay, let me just move on now to talk about sort of the philosophy of our program. First of all, we emphasize very heavily collaborative learning and project-based assignments. So in most of our courses, you'll find there are labs, either software labs or hardware labs, and typically students work together in teams to tackle a very meaty and challenging project. Okay, let me give you a few numbers that I think you're interested in. First of all, we have a very high retention rate in engineering as a whole, and EECS is consistent with that. So this is not a program where we bring a whole lot of students in and put you through some kind of torture to see, who's going to stick it out and who's going to drop out. Our students come in and stay in the major. We have 97% retention rate, well above the national average, and consistent with the whole campus. Has a first-year retention rate of 97%. That means that 97% of the students who enter as freshmen stay on and go on to their sophomore and junior years. The average time to degree is actually slightly under 4 years. Some students take extra classes or take courses in the summer. Summer courses are not required, but they are available. And the graduation rate is 94%. So while I say 97% students make it through the first year, almost all of them make it all the way through to graduation. 94% of our entering students graduate with an average GPA in the EECS major of just under 3.5. And a large percentage of our undergraduates actually take a double major in EECS plus something else, 11.5%. Now, we're very proud of the fact, and we put a very high value on having our faculty be very focused on teaching. So one way to see that is that over 96% of our courses are taught by department faculty members, not by TAs or outsiders, but by the EECS department faculty. And our faculty members teach both at the undergraduate and the graduate level. And every course involves, at the end of the course, student evaluations. So at the end of every class that you take, you'll get an evaluation form to fill out, and this is an example of and those evaluations are the summary evaluations, the averages and so forth are posted online, and you can look up by faculty member or by course how students rated those courses in terms of teaching effectiveness and how worthwhile was the course. And these evaluations are considered as part of the advancement or the, how much of a raise or promotion faculty get. So we put a lot of emphasis on how, on our teaching and, how effective we are as measured by the feedback that we get from the students. We have a number of teaching awards. I'm going to show you, some of the winners of these teaching awards, but the department recognizes outstanding teaching with a number of teaching awards. And these awards are highly coveted. Faculty, are very proud to win these awards. And we put, as I say, we put a high value on teaching, and the faculty are very proud of their teaching accomplishments. So here's just a little bit more on that. There are some campus-wide teaching awards. The UC Berkeley Distinguished Teaching Award is quite prestigious and competitive. They only give a couple of them each year. And here's a list of about 6 faculty who've of our ECS faculty member who have won the campus-wide Distinguished Teaching Award. In addition, there are a couple of other campus level teaching awards and a couple of other of our faculty who have won those as well. Now, speaking of faculty, I wanted to introduce to you some of our most recently hired faculty. And I'm not going to go through them one by one, but here are 7 faculty who were hired and started last year. And you can see there are a number of them. Most of them are quite young, fairly recent graduates themselves. A couple of more senior people. I already mentioned Jennifer Shays, who came in to help run the Computing, Data Science, and Society program. And in addition, these are our very newest faculty that just started literally just this semester. And some from on the EE side and some on the CS side. So we have a number of, very energetic, excited, and dynamic new faculty just joining us that bring a lot of, energy and enthusiasm to the program. Now, I'll just say a few words about faculty-student interaction. We have a lot of programs and venues where we bring students together with faculty. Every faculty member holds weekly office hours that are open as an open door for students to drop in. Mostly students who are taking that faculty member's class will stop by to get help or ask questions. But those office hours are open to any student who wants to come in and talk to the professor. Maybe you want to talk about career plans. Maybe you want to talk about internships. Maybe you're interested in getting involved in some research on campus. We have a program where every student meets with a faculty advisor each semester at the time when you're getting ready to select which courses you're going to take in the following semester. And unlike a number of other schools, rather than assigning every EECS student a faculty advisor, we let the students choose. So almost all the faculty serve as advisors every semester. And at a certain point of time in the semester, a couple of weeks before it's time for you to select what you're going to take next semester, you can go and look through and sign up for an advising session with whichever faculty member you feel is going to be the best fit for you. We also have a number of programs at the informal level where we have lunches. Of course, we haven't been having those during the pandemic, but hopefully those will start up again next year. And there's a monthly event where we serve lunch and students come to meet with faculty. We also have Friday afternoon kind of mixers with snacks. These are called undergraduate social hours. Now, I want to introduce to you this team. These people are very important to the guidance of our students. These are our undergraduate advisors. So we have these folks are not professors; they are professional staff who specialize in helping undergraduates get through their program. And we have a big staff. We have a big program. As I mentioned, we have almost 3,500 undergraduates. So we have a lot of people here who serve in various roles to provide support and help to students. They serve as advisors. I already talked about faculty advisors, but the staff are also there to provide advice on, some of the rules and how you can navigate through various things. Some of them help with scheduling courses. Some of them help with actually running courses, the course managers. And these folks are there to provide, extra help. Now, the people I just showed you are associated with this group on the right-hand side, the EECS Center for Student Affairs. And these are some more details on the kinds of help that those folks provide. Helping you to figure out course scheduling and making sure that the courses are scheduled into the right rooms and so forth. They help with the process of matching students up with faculty advisors. They help run some of our programs like our honors program, our internship programs, etc. Advising for grad school admissions. That's another important service that you can get from our department Center for Student Affairs. Now, on the left-hand side here, this is the College of Engineering also has an office they call the Engineering Student Services. That provides student advising support for students, all students in the College of Engineering. And they provide a bunch of services and programs that you can benefit from that are there not just for ECS students, but for the whole college. Various workshops, professional development programs. We have a psychologist, we have a counselor, a psychologist who is, we actually have more than one, that are there to help students who are having, various kinds of issues, mental health issues and the like, career services and so on. And both of these organizations, the EECS Center for Student Affairs and the College of Engineering, ESS, Student Services, are there to provide an additional avenue for support. We want you to be successful, and we provide as much help as we can. The faculty are there to help, but also we have this large organization of professional staff to provide additional support for students, help for you to navigate through what is a complicated and a challenging part of your life, is getting through our program. We provide, it's not easy. I'm going to tell you that right off. It's a challenging program intentionally, but we want to make sure that everybody is successful. And so we provide all kinds of support to help people, to help you navigate the program, understand, all the different moving parts and how to best take advantage of all the opportunities that we offer. Other types of support, tutoring. So the college ESS, the Center for Engineering Student Services, has some programs that offer tutoring support. The Eta Kappa Nu, HKN, is the EECS Student Honor Society. They provide tutoring support in various classes. Already talked about advising. We also have some student groups that provide mentoring. For example, the Association of Women Engineers, Women in Computer Science. There's also a program called Computer Science Mentors. These are volunteer students in the department that are available to help out one-on-one with students in most of our large courses. Now, in addition to the support from the advising and the department, we have a large number of student organizations that students, for students to team up, work together, help each other in some instances, or do fun stuff. Here's an example of some of our student groups. First of all, these groups here are students who, with common interests, meet together. We have a couple of honor societies, the Institute of Electrical Electronics Engineers, IEEE. There's a student organization, Society of Women Engineers, the Association of Undergraduate Women in EECS, Out in Science, Technology, Engineering, and Mathematics. That's basically a group of mostly LGBTQ students. We also have a student group of Black engineering and science students, Hispanic engineers and scientists, and a number of other groups of students who kind of come together with these kinds of mutual common interests. In addition to that, we have a number of student groups, clubs that really focus on different kinds of other activities. Like we have several hacker groups, students that get together for competitive programming or just working on developing various kinds of software. There were a couple of robotics clubs, unmanned aerial vehicles. There's a group for theoretical computer science and many other course student groups like this, both in the department and also in the college. Electric cars, various kinds of racers, and so forth and so on. So a rich number of different organizations where students get together with common interests to do things together. I want to say a word about entrepreneurship. Lots of students get involved and are very interested in starting companies or getting involved with startup companies. And, you know, our faculty and alumni, I think we're up to 118 different companies that have spun out from the EECS department. 11 successful IPOs so far. Recently, venture capital companies have been investing in some of our companies. Here are some names you may have heard of: Cloudera, Databricks, etc. There's a program to sponsor faculty to help start up companies on campus. So this is a program that supports innovative research by early career faculty. A number of our faculty have have participated in this Baker Fellows program. We have a program called Excel Scholars, which is run by a venture capital firm, Excel. And this is a program where they form a student group, provide mentoring and professional development to foster entrepreneurship for opportunities for our students. Another really important feature of the EECS department is we're the founding department for the Jacobs Institute for Design Innovation. But this spans all kinds of design activities across the campus. It's a special building for design studios, teaching and collaboration spaces, fabrication labs, maker spaces, and so forth. It has large design studios. This is a class taking place in one of the design studios. There are also student groups and others who use these design studios. Here's a picture of the metal shop there. Various maker spaces that either are used by classes or by individual students. You can sign up, you can get a maker pass, and you can go in and do your own thing after hours in the maker spaces in that Jacobs Institute. Here's some 3D printers that are available there that are very popular. Now to just talk about some things coming up if you do come to Berkeley. Undergraduate research. About a third of our undergrads get the opportunity and choose the opportunity to do research work in faculty research labs together with graduate students. And this is a way for you to, get a more kind of hands-on experience with research. These projects are not the kind of projects that you typically have in a class where you know that the project, if you follow the directions and you're going to be able to get that project to work. Research is all about, sometimes projects don't work out. We're out to discover new things. And so undergrads do get an opportunity to participate in the advanced academic research going on in the department by the faculty. There is a clearinghouse, an online forum for students to get connected up with research opportunities. It's called Beehive, beehive.berkeley.edu. Here's an example. Here are a couple of examples for opportunities that are posted on Beehive to work on sensing or programming. We have a very close partnership with a large number of companies who are out to recruit our undergrads to do summer internships. And every year we have a fair where the companies come and students can attend and talk to representatives from these different companies in order to sign up and apply for summer internships at these companies. To just show a few of the companies that participate in our internship fair, you can see the logos for some of these very well-known companies. I also want to tell you about our honors program. There's an honors program for exceptional achiever students that typically enter after your third year. You choose an academic concentration outside of the department, a special faculty advisor, opportunities for research experience. The fact that you were participant in the honors program does appear on your transcript. And we have some social events as well for the students in the honors program. We also, I mentioned this already once before, we have a 5th year master's degree program for our undergrads. It's an opportunity for our students to stick around for an extra year and complete the requirements for an MS degree within 1 year after obtaining your bachelor's degree. You apply in your junior year, and there's a minimum GPA. You need to basically form a relationship with a faculty member who will be your advisor for your master's thesis. And we tend to emphasize, students in this program to do some interdisciplinary work, maybe involving work with in another field besides the one that you've been focusing on in your undergrad. 8 units of coursework outside of EECS is required, again, to sort of promote broadening your background. And this is a great program. It's been growing. And the students that go through this program are very popular in industry and typically go on to very successful careers. Okay, a few more words about what you can do with when you come out of Berkeley with an EECS degree. Some students go on into postgraduate work in graduate school or a professional school like medical school or some other kind of maybe optometry or some other kind of profession, business school, law, medicine. Many of our students, a large number of our students go out to work in industry, in the information technology industry and biotechnology. Some of our students join up with consulting firms. Many of our students get involved in either new startups or helping to form a brand new company. Here's some examples: developing of multimedia, electronic products, graphics, animation, software for helping children and adults with disabilities, wireless sensors for health, the environment, et cetera, tiny robots for non-invasive surgery. Current number, average starting salary for graduates from our program is currently $115K annual. And usually, students going into industry get additional opportunities for bonuses and et cetera. Berkeley has a reputation for students that come out of Berkeley. Our alumni are a really unique breed. What we hear back from our alumni as well as our industry partners is that Berkeley students really stand out as leaders. Students, people who are self-starters that, have ideas and know what to do without requiring a whole lot of guidance. And having a lot of, on the ground street smarts. A lot of our projects and our undergraduate research and our other programs really give our students the ability to really know what they're doing when they hit the ground running in industry, internships and et cetera. And our students, these are quotes that we actually got from some of our industry friends. Our students really are go-getters and have a great can-do attitude. More so than some of the competition, really, even some of the top competition. And here are some photos of some of these were the 4 distinguished alumni that were recognized just this past year. And these are leaders in industry and academia. So just to summarize, Berkeley EECS is a really exciting, vibrant, dynamic community. We have a leadership role in research, and our leadership in research is key to us really continuing to evolve and improve, update our curriculum. so that the courses that you're taking are constantly having elements of the latest of research really, feeding into the courses. So they're right up to the minute. Our program has a high degree of flexibility. I really want to emphasize that, very different from what you'll find at many of the other schools that you may have already been accepted into. We have 6 required undergraduate programs. After that, our in major course requirements are extremely flexible. You have to take 20 units from our upper division. We do ask you to take a capstone design course, but there are many options for that, all the way from, across from the EE up to the CS side. Strong emphasis on teamwork. And so, we have a strong commitment, as I've tried to communicate, to education, close ties to industry, and a very supportive environment. So again, the EECS advisors, I've already introduced them to you. Many of them are going to be available. We'll have an online question and answer session with the advisors later on. I know this is a recorded talk. Normally this would be a live talk and our advisors would be here with me at the end of the talk to answer your questions. But in this case, they're posted. I think you are aware of when we're going to have the online Q&A sessions. And we also have this link here, which will take you to the online website for our advising program. And if you don't have time to scribble down this URL, just go to the eecs.berkeley.edu and look for our section on advising. It's easy to navigate through our website to get to this, in fact, to get this exact web page. So again, congratulations to all you new admits, and I would hope to see you in Berkeley next year, and enjoy the rest of Cal Week. So thanks very much, and go Bears.